Hi, and welcome back to the Lernard.com chapter on Jenkins. In this chapter, we're going to have a look at the simplest possible type of automated build, that of the freestyle project. A freestyle project may sound something like an 80s skate park, but in fact it's the simplest possible type of automated build, configured manually in the Jenkins GUI, rather than being defined in code. This means that it's not proper DevOps, as it can't be version controlled, but it is a great way to learn the purpose of Jenkins and to get a feel for the dashboard and how it works. As per usual, we're going to be expanding our so far rather simple diagram now to contain integration with Git. By entering Git details into our freestyle project, we're going to allow Jenkins to clone directly from GitHub to build into a working web server. We're going to link Jenkins to the React example site we looked at in the last section and create a freestyle project to automate all the steps that I manually demoed when we were looking at it, and then to deploy that site to a remote web server. So, without further ado, let's jump onto our VirtualBox Ubuntu VM and get started. In the previous section, we installed Jenkins onto our Ubuntu box, and as we enabled the service, it should always be running. So let's open a browser window and browse to http localhost 8080 to get back to the Jenkins main dashboard. We'd normally see a list of build jobs here on this main dashboard, along with a handy icon for whether or not the last build was successful. But as we don't currently have any build jobs yet, it's just blank. Let's get to making one of these straight away by clicking in the top left here on New Item. I'm going to give it the name Section 3 and select Freestyle Project here. The description here says this is the central feature of Jenkins, but I think most basic feature of Jenkins is a more accurate description. Now we can click OK to create our project. This next screen is the project configuration screen, where all the settings for our build project go. We can get back here at any time after we've made the project by clicking Configure, which I'll show you shortly, so we don't have to get all the things we want down here in one go. We can build them up step by step as we go along. Let's give it a description here first off. Now, the first thing we want to do is connect this to the Git repo we're storing our code in that we want to build. So, let's scroll to Source Code Management here and select Git. As you can see, we've now got a field to enter the URL of the repo. So first we need to go and grab our example web app URL from GitHub, as that's what we're going to be building in all the sections of this chapter. So I'll just browse to github.com. Click on the example web app here, though in your case you probably need to search for it as you're not logged in as Lernard. And now click this attractive green button here as always for the download link. Now this is the SSH link, so I'm going to change this to use HTTPS so that instead of using an SSH key, I can use a username and password. Jenkins absolutely can use SSH keys, and generally you probably would, but just for the moment I'm going to take the easy way out and do it this way. Along with idempotency, automation and version control, my own personal fourth guiding principle of DevOps is laziness. Anyway, let's copy our URL here, switch back to Jenkins and paste it into the repo URL field. Now we need to add that username and password by clicking Add on the credentials field here. We're going to use the Jenkins credential provider here, as it's the only one at the moment, and in creating these, because they're global, we'll be able to use them for other build jobs that are pointing at the same GitHub account, which is great. Let's just populate the credentials in here. There we go. And now click Add. Now I can select those newly created credentials from the list here, and as I mentioned before, they'll be available for other jobs, so next time we'll be able to select them without having to go create them again. I'm currently glossing over the Build Triggers section, even though it's very important for our dream of a fully automated system that automatically detects changes in Git. But at the moment we're just focusing on the most basic case, and we'll come back to this properly in later sections. Right, we've linked our project to Git, so now we're going to need some build steps. Let's click this tempting looking Add Build Step button here, and we can see a list of the sorts of things we might want to do as a step in our automated process. Several of these, such as Invoke Gradle script, exist there because we have the plugin installed to provide that service, and there's a whole lot more types you could feasibly add to this. But at the moment, we're going to do everything using command line based steps, so I'm going to select Execute Shell. I should say at this point that some people in industry frown upon excessive use of shell-style steps like this, rather than using bespoke steps designed for the exact task you want. But having worked places that do both, I don't feel passionately about it. Especially once you get to using everything in a pipeline as code, I've never actually had much problem making heavy use of shell steps, even in enormous deployments. So my advice to you would be that whatever your boss says is the right way to do things at the time, just say, "Excellent choice, sir," and you won't go too far wrong. So, here's our first build step, and as it's execute shell, whatever we type into this window will be executed as a shell command for the first step in our project. We've already been through these steps manually in the last section, so we know that our first step is going to be to download and install our dependencies using the npm install command. So I'm just going to write npm install in here. Now I've done that, I'm going to add another build step of the same type. And now I'm going to write our npm run build command, which will work its wonders on our code and output a build directory of nicely servable web content, all minified and compressed for us. For the moment, I think that's enough build steps, just 2 to keep it nice and simple. Let's save this and give it a test drive. We can kick off our newly created project by clicking Build Now here. You can now see in the build window in the bottom left-hand corner that a build has started, job number 1, which we can click on to see console logs of how it's going. You can see here that so far it's gone to Git, it's cloned the project, and now it's going to go through the npm install part of the build we created, installing the project dependencies required to make it work. Some of you may be wondering at this point where exactly it's installing these, which would be an excellent thing to wonder, and we're going to get to that very shortly. OK, with a bit of help from Fast Forward, it's finished, and it's saying success, which is good for us. You can probably see at the end of this log here that after npm start, it also did our npm build. So now we have a built version of the project in a directory somewhere, though currently not doing very much. If we scroll back to the top and revisit our Jenkins main dashboard, you can see now our build is listed there. The blue sphere here means our job was a success, and we can see here as well that the job took 3 minutes and 49 seconds to complete. This dashboard can be a really useful place to check everything is working at a single glance, and often in industry this information will be displayed on large televisions scattered around the room, so developers can see when their last build happened and whether or not it was successful. In some places it can be a tradition that anyone who breaks the build has to then go and buy edible treats for the rest of the team, which explains why I've yet to achieve the on-screen physique I was hoping for. OK, let's jump back to our project, and now we have some additional preparation before we can go on to our next step. What you personally are going to need to do now will very much depend on whether you have come straight to this chapter or whether you first went through the Terraform and Ansible chapters. For the next step in our build, we're going to deploy our newly built website to a web server, which means we're going to need a working web server to deploy the site to. I'm going to go and spin one of these up using Terraform and then configure it with Ansible, because the last 2 chapters focused on creating the code to do just that. If you've come straight here and you don't want to learn how to do that, then you'll need to create yourself a web server manually. This isn't a problem at all, as there are 2 sections in the basics chapter to help you do that you can follow, called Spinning up a server in AWS and Installing and Configuring Apache. Each of them takes about 20 minutes. Or, if you are comfortable spinning up an Apache server somewhere under your own steam, just go and do that, as it's all we're going to need. For those of us treading the righteous path of DevOps, let's continue by heading over to the terminal to use our Terraform and Ansible. If you'd like to follow along with us but don't have the code, remember that all the code I create in these courses, including the Terraform and Ansible I'm going to reference here, can be cloned from the Lernard github.com repo. Before we spin up our machines, I did promise I'd show you where Jenkins is cloning our example repo and building the actual project. Jenkins stores most of the things you'd want to mess around with at /var/lib/Jenkins. You can see here, if I list out the contents of that folder, that there's a lot of useful sounding things in here. Plugins, jobs, logs, etc. But in our case, we want to head to workspaces. Another quick list shows us that our project is there. And if I tidy up a bit here and then take a look inside, we can see what looks a lot like the example code we cloned, and sure enough, there's the build directory there. So this is the folder that Jenkins has done the build in. And I can see here that inside this folder is all the stuff we're going to need to copy to the web server to make it serve our site. We can actually choose whether or not this folder gets its content erased and replaced on each build, or whether that content will persist. It can be a time saver to persist because it dramatically cuts down the time for an npm install to download all the dependencies. However, sometimes it might cause odd effects if files are not deleted properly, so we want to just pick depending on our specific use case. In this case, because it's a nice simple project I'm not going to alter, I'm going to let it persist. OK, so now we know where the code goes, into /var/lib/jenkins/workspaces. So let's make a mental note of that, as we're going to need that info soon. Let's cd back to our home folder, and then into the repos, Ansible, Terraform web server folder. If you don't have this folder and you're looking to get hold of the code from GitHub because you haven't got your own, it's the Ansible repo and Lernard that you'll need for all the stuff we're about to do. And you'll also need to run the AWS CLI tool to connect to your own AWS account for these tools to work. Full instructions on how to do this are available in the Terraform chapter of this course. I've got nothing in my AWS account at the moment, so I'm going to run a Terraform plan. It's saying 5 to add, which definitely includes a couple of extra bits I don't really need, like a DB server. But I don't really care, as we're only going to be using them for 20 minutes or so it probably won't cost anything, and then we can just spin them straight down again at the end. So, I'm happy with that, so Terraform apply. Great! Now my servers are ready to go. Remember to make a copy of the IP address of the web server there, as we're going to need it in a moment. Now we've spun up our servers, we need to apply some Ansible to them. The most complete Ansible we created was the stuff in the section 6 folder of the Ansible repo, as it's the last one, so let's cd in there now. The first thing we need to do here is configure our hosts file to point to our newly spun up server. So, vim hosts, and now we can paste in the IP address of the server we've just created. And amazingly, that's all we need for the config. Now we can just run our familiar ansible-playbook-i hosts playbook_web.yml command, and all the inconvenience of configuring a server with Apache settings is handled for us. For those of you that have followed the DevOps star all the way with me, you can hopefully re-experience the magic of how incredibly convenient these infrastructure as code tools are, that we've been able to spin up a fully configured Apache server here in mere moments thanks to code we made previously. And the more complex the spin up you're trying to achieve, the more time you can save. I can spin up my entire personal company in under 10 minutes, even though it has literally hundreds of moving parts to it, and even spin it down again overnight to save money should I wish to. Anyway, there we go. Our Ansible is complete. And if we want to confirm it truly has been successful, we can open a browser tab here and browse to the IP of the server. And sure enough, it's serving our index.html placeholder we created. Now we've successfully configured a web server, we have a target for Jenkins to deploy our code into. In reality, in industry, this web server might be hundreds of web servers in a huge farm, as we discussed in the basics section. But that's okay, as the principle is identical whether there's just 1 or 100. Automated systems don't really care about scale the way people do. For Jenkins to be able to access our web server, it's going to need an SSH key. You might think that Jenkins could just use the key we've got in our home directory, as our Ubuntu VirtualBox VM can already access that web server we created by default. But in fact, Jenkins has its own default path for storing keys, so we need to copy the key over to there for it to work. For those of you doing all this by hand, you might need to create a key pair using SSH keygen first. I do go into this in a few of the sections, and you can also just Google that online. So, with that in mind, let's write sudo cp, the location of our SSH key, which is the SSH directory of our home folder, and then Jenkins expects this key to live in /var/lib/jenkins like before, and then /.ssh. This step might not seem very automated as we're doing it manually, but in fact in reality we'd be using Ansible to create our Jenkins server as well, so we could have the whole process controlled and automatic. We're only doing this manually at the moment so we can go through the steps together one by one and gain an understanding of what's going on, without adding the confusion of another layer of automation too early on in our learning process. Now we've copied that key, and because we used sudo to do so, it's going to be owned by root, so we need to change the ownership to Jenkins using sudo chown Jenkins:/Jenkins and then the location of the key. Okay, so let's recap. we're going to make Jenkins deploy our built site to a web server. So far then, we've created 2 build steps to install all the dependencies and then to build the site into the workspace folder of the job. We've also spun ourselves up a web server to deploy to using Terraform and Ansible, or you may have created yours manually. And we've given Jenkins the SSH key required to access that server. Now all we've got to do is add the final build step to actually perform the deployment. Okay, let's switch back to the Firefox Jenkins tab, and in the project section 3, we're going to click on Configure on the job, and this will take us back to the screen where we can add more stuff. If we scroll down to our build steps, let's add one final execute shell step for our deployment. In this case, we're going to use SCP to copy the files across, which might not be a thing of great complexity or beauty, but it's a classic. So, SCP-R for recursive, and then -V for verbose, so our logs are nice and meaningful. I'm going to specify a -O for option, and then choose strict host key checking equals no. And then another option, and user known hosts file equals /dev/null. These options are grabbed straight from Google to stop SCP from needing a user input to confirm the servers we're connecting into are legit. Don't worry about learning them, as Google is only a click away if you ever need them again for your own projects. After that, I'm going to enter the path to our local build folder that Jenkins is using here with our nicely built code in it. And then the path to the web root on the remote server we've created. So, Ubuntu @ then the IP address of your server, then a colon, then the path to the web root, which is, of course, /var/www. and then in my case, /www.lernardtest.com, though if you chose a different site name when you made your Apache server, then of course use that. OK, let's save that, and now we can run another build and see what happens. I'll just click on the build here, and we can select console output to see some logs. We can see it's doing the npm install step here. And now it's doing our npm build. And now, finally, it's copying all the files to the server. And OK, success! Let's go and check if it was really successful by refreshing our page. And yes, as you can see, our beautiful Lernard React page is now displaying. So Jenkins has automated the build process for us, and then successfully deployed the site to our remote web server. And having reached that high point, we're done with this section. Hopefully you can now see how Jenkins is taking something that was formerly manual in the build and moving it into the realm of the automatic, just as Terraform and Ansible did for our provision and configuration steps. Still, this isn't proper DevOps yet, because it isn't version controlled and it isn't codified. We're going to rectify that in the next section by taking a look at Jenkins pipeline as code. Hopefully see you there.